Yes, good evening, everyone. Am I audible?
Yes, sir.
I think we must start.
Okay, sir.
Good evening, sir.
Good evening, everyone. Good evening, sir.
Good evening, Mrs. Nadia.
Thank you, sir. Good evening, everyone, all the participants. So I welcome Wayan Budi Sentana, sir. He is connected with us as an expert speaker from Indonesia. Am I audible?
Yes, madam.
Yeah, okay. So I welcome, sir. He is connected with us from a long distance from Indonesia. I would like to introduce Budi, sir, to everyone. Sir is a graduate from the Department of Computing at Macquarie University in August 2024. His research focused on the implementation of blockchain to prevent IP prefix hijacking in border gateway protocol and on the security and privacy analysis of mobile application. Currently, sir is a senior lecturer at Polytechnic Negeri, Bali in Indonesia, working on the identification of online gambling advertisement infiltration in official websites. So has 22 years of working experience and a tremendous contribution in the field of academics and research. Let me just give a brief introduction regarding his research projects and funding. In 2003, Sir has worked in a project, Hybrid Genetic and K-Prototype Algorithm to determine optimal cluster for mixed data type, which is funded by Ministry of Research, Technology and Higher Education of Republic of Indonesia under the Junior Research Scheme. In 2014, Sir has worked in development of Android-based preschool mobile learning application. This research funded by Ministry of Research, Technology and Higher Education of Republic of Indonesia under the Junior Research Scheme. Then in the span of 2014 and from 14 till 2016, so worked in a project that is development of IT utilized knowledge transfer model in Balinese handicraft small and medium enterprises, which is again funded by Ministry of Research, Technology and Higher Education of Republic of Indonesia under the Applied Research Scheme. In the span of 2017 till 18, the project in which Sir worked is lung nodule detection on computed tomography imaging based on parallel computing of CPU and GPU. Again, it is a funded project by Ministry of Research, Technology and Higher Education of Republic of Indonesia under the Fundamental Research Scheme. From 2018 till 2019, the project is Android-based integrated tsunami evacuation route guidance information system, which is funded by Ministry of Research, Technology and Higher Education of Republic of Indonesia under the Applied Research Scheme. From 2019 till 2023, Sir worked in a project that is blockchain technology in securing network protocol. This project is a part of his PhD thesis and funded by Indonesia Endowment Fund for Education and supported by Macquarie University Cybersecurity Hub. The project, his recent project is, it was from 2020, it is from 2021 till 2023, okay, and the project name is Mobile Application Security and Privacy Analysis. This is again a part of his PhD thesis and funded by Indonesian Endowment Fund for Education and supported by Macquarie University Cybersecurity Hub. So list is long for his selected publications, and Sir has bagged many achievements and awards. Like in 2012, he was awarded by Lectures Excellence Award rewarded by STMIK Bali. Then in 2017, again Sir bagged Lecturers Excellence Award rewarded by Bali State Polytechnic in 2019. Sir was an awardee of Indonesian Endowment Fund for Education. Then Sir is one of the finalists of Cyber Thesis competition conducted by University of New South Wales, Sydney in 2022. And in 2024, Sir was awarded by Bronze Award 24th Malaysia Technology Expo in category of International Innovation Awards. Sir has many more achievements and a list is very long. We are glad to welcome you, sir, over here in this FDP, and we would like to hear an insightful we would like to know insights from you on the topic security and privacy on mobile health and applications. Welcome you, sir.
Yes, thank you very much, Mrs. Sadia. Should I call you Miss Sadia? Sadia Patka?
Thank you so much, sir.
Yeah.
And,
Yes.
you are the one who is pronouncing my surname very correctly. Most of them pronounce it Patka, but it's Pat. And thank you so much, sir. Thank you so much.
Yes, it's really coincidence because our dialect, maybe Balinese and India, are quite the same.
Okay, thank you, sir. Thank you. You can proceed with the session, sir.
Yeah, so I will ask your permission to share my screen. Yes, okay, I hope my screen can be on your side. Sorry. Okay, can you see my slide now, Mrs. Patka?
Slides are not visible, your screen is visible.
Okay, so not visible then. Let me try again. How about now?
No, it's not visible.
Okay, I'll try again. Yep, hopefully it's visible. Is that now? Not yet?
Yes, visible, sir.
Okay. Yep. Yeah, thank you very much. It seems that I have some problem with this navigation, so sorry for that one. Yep. Okay. I hope I put the right picture over there. So this is Anjuman College of Engineering and Technology. So my name is Wayan Budi Sentana. So you can call me Budi. I'm currently serve as a lecturer at Polytechnic Negeri Bali, and I had some research previously that related to the security and privacy analysis in mobile health application, because the topic of this event is that something that related to AI and also artificial intelligence in health related field. So I think this background is already mentioned by Ms. Parka a few moments ago. So I just graduated from Macquarie University. So actually I already submit my thesis since 2023 and I have some experience to serve as a research fellow at Macquarie University Cybersecurity Hub. And then I finished my master in Indonesia, in Surabaya, and also my bachelor program in Yogyakarta as well. And then I have a few, only a few certification that related to my fields, which is cybersecurity and also forensics. So including that EC Council Certified Computer Hacking Forensic Investigator, which is giving some experience on how to do forensic investigation after the attack occur on a certain can be say like a medium like a mobile device or mobile computer. And also I have some experience in a DevNet associate provided by Cisco. So this is more likely like how to create or can be infrastructure to build information system based on microservice. And then this part is already mentioned previously. So I feel grateful that I have some experience to follow some can be said as a competition and have some reward for that one. And then I'm currently still serve for the Polytechnic Negeri Bali. So as you may aware, so Polytechnic Bali is located in Bali Island, which is in Indonesia. Maybe some of you already heard about Bali. Bali is one of the most famous tourism destination and even in the world. The topic that I try to share with you now is that related to the mobile health application, especially that related to the security and also privacy analysis. So as you may aware now, if you have a look on your device, I'm sure at least you have one mobile health application. For example, if you're using smartwatch, like my wife, that's quite crazy with the to achieve like a 10,000 steps per day, and she then start to buy some smartwatch that connected to the mobile phone, and then try to install some application that related to to keep the healthiness of the body conditions. That's we can categorize as mobile health apps, and this the number of this kind of application is increased significantly currently in Google Play Store and other repository in the internet. So that's why this one become a background for my research. Actually, I did my research since 2020 when which is a part of my PhD thesis actually. So the background of the reason why I choose this topic is because again the increasing number of mobile health application and also the increasing the number of user that try to install this kind of application. And other than using application, there's some risk that maybe use or occur to this kind of application. The first or maybe the most problem that maybe occur or risk that maybe occur is the leak of the personal and medical data. Maybe for us in Indonesia and maybe have the same character in India, if we have our medical data or our personal data leaked on the internet, it wouldn't be a problem. But for some people, especially that coming from European country or people that coming from Australia, and they're really aware about that one, about their personal data, about their medical data. So when they have their data distributed on the internet, and they will become so crazy and make some concern about that kind of things. So maybe it's not very important for us in Indonesia. I mean, if you can easily find my data, my ID data, my even my insurance data in the dark web easily, because Indonesian government don't think that this kind of data is important for them. But for some people, this kind of data is very sensitive and need to be protected. And then a few cases of data breach is also increasing the concern on how to protect this kind of data, medical data, especially coming from mobile application, because it can easily intercept and can leak to a third party and different purposes. Then the number of regulation that created by European country and also some Australian, they getting aware of how to create some rule or law that can protect this privacy, such as HIPAA and also the GDPR in Europe. So that's become a strong reason on how important this research need to be conducted. And then there's also can make like a suggestion for the developer on how to create a balance between usability, security, and also privacy. Because usually when we're talking about the security, it will be so challenging in the view of usability itself. So this research stage, as I said before, it started in 2020 and finished in 2023. So quite big project that I did, because it's not just in the mobile health application itself, but also in different type of mobile application. So basically, we do the same research stage. The first is the apps discovery. So we try to use repositories such as Google Play Store to find a certain number of mobile application. So, when I mention about mobile application, means that I'm working with the Android applications, and after we found the apps, and then we start to do some metadata analysis. Metadata analysis is try to find the user perception about the application itself. And then static analysis. Static analysis means we try to decompile the application, and decompile means we can recreating or do some reverse engineering to the executable file, and create recreating the source code of the mobile application, and then we can analyze the security of the code. That is the static analysis base. And then we also have a look on how the application is packaged, because packaging in Android application like a whole very important part of the application, especially in the form of security itself. And the last analysis that we did is related to the dynamic analysis. In this case, dynamic analysis means that we try to run the application on the simulator and also on the real device, and then we try to capture the network between the device and also the server, and we try to have a look whether they're using a secure connection or not, because if not, we can easily intercept the data flow from the device to the server using a certain tools. And then the last stage is reporting and presentation. So we will have a look this stage one by one. So the first stage, we call this three-stage app discovery, because we create like some kind of standard for our research stage to find the apps in the Google Play Store. So as you know, now the security of Google Play Store is also increasing. So it's not very easy to download the application directly to computer, but you need some device to do that. So we have some strategy to download like thousands of applications from Google Play Store automatically using this stage. The first step in this stage that we did is to find application that related to the mobile health application. So we are using Google Play Scraper and Python and combine these two tools to create some automatic crawler or automatic scraper of the metadata. So we're using some keyword like maybe mobile health, health and fitness, and some kind of words. And then by using this combination of tools, we try to scrap the application. And the second step is, this is quite exhausting step because we did some manual filtering based on the application to make sure that we are downloading or we are working on the right application. Means that all the application that we have is related to the mobile health applications. And the last one, we did some research on what kind of tools that can be suitable to download all of these applications automatically, because we're not talking about one or two applications, we are talking about thousands of applications. So we need to make some automation so we can download this the list of applications that we have from the previous stage automatically download it to the our computer. There's a few application that we used before, like a Gplay CLI and also Raccoon, but now that kind of tool is no longer working since the increased level of security in the Google Play Store itself. So this is the 3 stages of app discovery. So we will have a look one by one on that 3 stages of app discovery. The first steps of this app discovery stage is to find the metadata. So there's some open source tools named as Google Play Scraper. This is NPM based or JavaScript based. So we try to combine with our scraper using Python, and we try to download the metadata of application using this combination or customized tools that we have, and then store the metadata, including the app's ID, app's name, app's developer, app's I think it's a short explanation about the apps, and also rating, and also some other detailed information that related to the apps, and store it in the JSON format. Then after we get the metadata, then we start to do some manual inspection, manual verification to make sure that all of the data set we have is related to the mobile health applications. And then after we have the list of the application in the JSON, then we try several tools. At first time when I start this project in 2020, I still can use Gplay CLI. So we can we just give the list to the Gplay CLI, then do some looping to download automatically from Google Play Store. But then at some point in 2021, this tool failed to conduct the process, and we moved to Raccoon. But then in 2022, if I'm not mistaken, this tool is also failed to download automatically from the Google Play Store because the Google Play increased their security. And finally, in 2023, until now, we cannot use those tools anymore. So we create like our own mechanism. So we have some, we are using the real device. At first, we are using simulator like a Genie Motion, or also emulator from Google, the SDK, Android SDK, but then there's a few drawback, and then we're using a real device. And the device is connected to the computer, and then from the computer we create like a small scripting, and based on the list that we have from the previous days, we try to download it one by one from Google to the device, and from the device we pull the APK to the computer. Why we should do this? Because the Google Play Store now create the bundling of APK. APK is the distribution package of the Android. So when you install the Android application on your device, actually that device is downloading a file with an extension of the APK or Android package. And the modern Google Play Store now, they create some security. So all the developer cannot upload APK anymore. They just uploading they call it Android bundle, ABD. And then when your device try to download some application from Google Play Store, they will create the package on the fly. So it depends on the type of your device, the series of the Google API on your device, and then it will create like a customized package for your device. So that's the challenge. So we try to hinder that problem by creating this kind of mechanism to download automatically to device and then pull it to the computer to get the file. Then in 2020 until 2021, we managed to collecting 20,000 applications that related to the mobile health, and we try to divide that application into medical related thing and health and fitness related applications. So based on this application, then we try to do some static, dynamic, and also user review analysis. So actually we did a lot of analysis. We in this paper that we published on the JMIA from the Oxford Press University, we just mentioning only a few analysis, including how this application is signing during the distribution, because it's very important related to the security. Means that if the application is signing using a good signing mechanism, means that the standard of the security is already fulfilled. But if not, then we can categorize that application is underperformed or under the standard. Then also we try to use VirusTotal to check whether the application consists of some malicious code inside of the application. It mostly can happen because a lot of developer, they try to embedding so many library from the third party, because maybe they don't know what is the inside of the library, and they just embed it into their application, and that makes some vulnerability inside of their application. And then also we have look on the intrusive, we call it intrusive permissions from the application to use a resource inside of the mobile device. This is the code analysis or the static analysis. And then from the dynamic analysis part, we try to capture if the application is using HTTP or HTTPS or using a secure connection to connect with the server. So to make sure that application is create a standard of data exchange between mobile device and the server. And the last one is related to user review analysis. It means that it can be taken from the comment and also rating that given by user or concern that provided by user related to a certain mobile app, mobile health applications. And this is some statistic that related to the application that we managed to download. So we try to categorize into medical and health and fitness. We have like 15% is a paid application, and the rest is free, and some application is like very blur, because it's geoblock is blocked by a certain server, because they're using a geolocation to detect where this kind of application can be running or not. And also we found the number of downloads. So most of the application have quite low downloads number, like a 500, means this kind of application is not very popular. The number of apps that have more than 5 million install or download is only like 0.6%. It's not that high, actually. Means that this kind of application is very popular. And also in terms of rating, most of the application, 29, like 40%, they have like a 4 to 5 rating. And from the user perception, like a positive or negative, most of them have like 20% to 40% negative review. Then that is the stage of finding the apps. The next stage is to do some method analysis. So for this stage, we are using the comment and also rating and user comment from the user that for each application on the Google Play Store, because Google Play Store they providing some medium, so the user can give some comment, whether it can be positive or negative. So we try to collect all the comment and find some terminology that directing to the positive or negative sentiment. And we are using some kind of library, language library, to detect the language that use, such as lang detect in Python language. Then the static analysis. So this tool is quite powerful for the decompiling Android application. This is a APK tool. So this APK tool will decompile the APK that we have from the Google Play Store, and it will do some reverse engineering to become like a Smiley code. So after the reverse engineering process, then we can have the source code of the application. And then the static analysis, basically we have to look on the source code, whether they have like a malicious code or maybe an insecure code that exists inside of the application. So this is the GUI version of the APK tool. Basically, they have at first they are developed in the command line application, and that application is very powerful and easy to embed in any application that you try to develop. And then after we have some decompiled version of the application of each application, then we try to have a look on the certificates signing mechanism. Currently, the signing mechanism in Android application is in version 3 or 4, if I'm not mistaken. It's quite a while since last time I did some experiment on this tools. So means that they have a few versions starting from version 1 until version 3. if application certificate signing mechanism using a version 3 means that it's already updated right now. But if we have a look on the Google Play Store, not all of this application have some update. So it means that they're still using the old version of certificate signing mechanism. So if we found any application that's still using version 1 or version 2 of the certificate signing mechanism, we can easily hijacking that kind of application and make a new version by using our signing certificate. I mean, we can have a full control of this application, like a hijacking the original application and make a customized version of this kind of applications. So we have a look on this certificate signing mechanism of that 20,000 application, and then the next one, we try to find any malicious code inside of the application by using a VirusTotal. Maybe some of you are already familiar with VirusTotal. So VirusTotal is a aggregation of around 70 engine, like a antivirus engine. VirusTotal try to make some aggregation and embedding all of this engine in one website, and they provide some API. So we send like a 20,000 application. We try to hash it and send it to the VirusTotal, and then from the VirusTotal, all of the engine will detect whether our application had some malicious code inside of the application. I'll show you the result afterward. Then we also have a look on the intrusive permission request. So basically, if you decompile Android application, you will find one file. We call this file as a manifest. It is an XML file. So this is the only file in Android application that cannot be encrypted because we call it manifest because all of the resource needed by this application, all of the API that request by this application will be mentioning on this file. So it's like a manifest. So that's why it's called as a manifest for the Android application. So since we can like a mining all of the permission requests needed by the application, then we can identify. Actually, Android, they have some categorization for the request. They categorize as a dangerous permission, normal permission, and also something that related to the third-party permission. So why this kind of analysis is important? Because usually when some application, they have like a very intrusive permission, means, for example, they try to access the contact of the device, means that they can do some interception or infiltration to another resource inside of the device. So so basically, Android device or Android application, they made quite secure. So inside of the device itself, you cannot access the resource directly. All of the data exchange between or among application is through the API. So only authorized application can access to a certain resource inside of the device. So that's the way of Android to protect the resource. So not all application can do some malicious activity. For example, they try to access the contact inside of the context books, for example. That's the way Android framework prevent this kind of infiltration happen. Then the last one is dynamic analysis. So basically, in dynamic analysis, we try to intercept all connection from the device to the server. So we create our own environment. So we create like our own proxy using MITM proxy and try to create some Wi-Fi access point through mobile device, and we automatically running all of the 20,000 application in the device and using some event activators such as Monkey to run to do some click to do some navigation to the application, so it can produce connection requests to the server. And then by using this MITM proxy, we try to capture all the network traffic that coming from device to the server. So this process is quite challenging. I mean, the connection is also, the connection protocols is also keep increasing their security. So when I start in 2020, we can easily capture the application network traffic, but then some protocol changes. All of the mobile application is required to use like a HTTPS and TLS protocol. Means that we have to do a little bit hacking by pretending to become a user, and then we install our own certificate in the mobile device, and then so the server can recognize us as a trusted user. So there's a lot of trick, and always challenging because the security level is also increased time by time. So after we got the traffic, we convert all of the pcap file into the hard file. So there's the structure of the file is quite different, so we can easily identify to which URL the traffic request is requested, to which server or to which IP address the request is ended. So then we use a certain repository to make sure that the IP address is not belong to the blacklisted IP address. And then this is the result that we published on the Jamia journal. So there's some interesting point that we found. For example, we found like 12% of this mobile application have FE score of more than 6, means that at least 6 antivirus engines detecting some malicious code inside of these applications. So around 47 application in total. And then also we found some Trojan inside of this application. And most of the malicious activity that detected by the virus detector is related to the AdSense and adware. So it pretends to become like a advertisement library, but actually it collecting more than just user information. For example, it try to detect the movement, geolocation, and also of course the Android ID, because AdSense library, they will need the Android ID to monetize their advertisement. But in some case, this kind of library is also become malicious because they can take over the whole screen, for example, like that one, and is very dangerous because they are running like we call it a frame. Web frame, and web frame can take over the whole application, and it's for some people or for some users it's quite annoying to have that kind of advertisement library. And then uh, we have like a 10 highest number of AV score of 24, for example, like Urdu best.k, for example, it has a AV score of 24, means that 24 antivirus engine is detecting this application as a malicious. And also like nursing care, it has like a 19 AV score, means that it has like a or 19 antivirus engine detecting that this application has malicious code inside of the application. The rating of this nursing code is quite high, 5, means from the user perspective, it has very high performance, a good performance, but it's only installed by 1,000 plus users. This it's quite deceptive fact that we found in this research. And from the user perception, we find a lot of complaint that related to the bugs, battery, mobile data, malware, and etc. So this is the statistic. So we found some complaints that related to malware, for example, in maybe like 6,000 comments. It can relate it to more than one application, but that's the number that we found. So means that not all of this application is quite safe, and even the user can barely experience the possibility of malware existent inside of these applications. And then this is the permission that requested, and quite a lot actually. And then we found from the dynamic analysis that some information is shared to the third party using bare HTTP without S, means that all of this data is distributed using like an unsecured connection. There's some information about gender and demographic, and also identifier cookies, GPS location, MAC address identifier, and contact password. Also, we found quite high, like maybe 80 application are sending the password in HTTP connection. Although the application maybe do some hashing, but it can be easily guessed by the interceptor. So it's quite worrisome for some application to have this conditions. And this research already published at two. The first one is a Journal of American Medical Informatics Association by Oxford Press, and also, if I'm not mistaken, this is published by Springer Nature. And also we have another publication and also related to the mobile application security and privacy analysis. It's not necessarily related to the health related field, but also because we did a lot of experiment that related to mobile application, and we try to find in a different field whether they have a similar condition with the mobile health applications. And I think maybe some of you already familiar with these tools. So the tools names is MobSF. So MobSF is developed by Ajit Abraham from India. So when I start doing this experiments in 2020, this tools is just introduced, and now this tools is developed very well. Yeah, and they have some like version of this application. So I'll show you some uh, yeah. So they have the live version of MobileServe, and also they also have the source code of MobileServe. So in case that you interested in mobile security analysis, they provide open source application, so you can use it and install it on your server, But I'll show you the live version, or maybe I'll show you the source code. So this application is developed in Django framework and using Python as a programming language. And then there's more and more people involved in this project, and they currently have version 4, means that the result is quite good, and more contributor is contribute for this application. But I'll show you the live version. Previously, when I did some research, they don't have this live version of their application. So this is the landing page of this application. So basically, you can upload some application and try to analyze whether your application is safe or not. So how we can find the application? So ideally, you can find it on the Google Play Store. But the problem is you need some mobile application. So instead of using this repository, there's some third-party repository. Let's say like APK, APK Mirror or APK Pure. This is the third-party repository, like this one. So this kind of repository, they try to create like the second option for the people to get APK or Android application. So let's say mobile health or health related application. Let's say this one. Yeah, you can download it. So the difference is this kind of application is already packaged in APK. It's quite different with the Google Play Store. Yeah, it takes some time because the size is sometimes quite big. Or maybe my internet connection is not that good, so it takes some time to download this application. So let's have a look if I have some previous application already downloaded. Let's say that, oh, okay, seems that I have some application here. Let's try to upload this one. Okay. So this live version, they use some load balancing. So your application is not directly analyzed, but you have to wait in the queue. So let's say like this one, Madam Health application. This is the application that we just uploaded, and they need some time to decompile the app and convert into Java, GADX, and then they will start to the application will start to do some analysis. It will take some time because this is public based can be accessed by public. So it's also use load balancer, and your request will be in the queue before it will be analyzed by this application. So let's have a look on the application that already analyzed. Recent scan, for example. So let's say this one. They have some reporting here. Static report and dynamic report. So static report, let's see. This is the information about this APK. The package name is always ended like this one. Yeah, the landing page for the first time is in the main activity, and then exported activity. This is the some analysis that can be done inside of the Android application. For example, exported component consists of 4, like exported activities, exported service, and etc. So why we need to be concerned about this exported component? Exported components means that this kind of component is prepared to be exposed by outside application. So let's say that you want to share some data, means that you have to prepare some gate. So the other application can access that data. For that reason, you have to make your gate exposed by outsider. So there's some standard to make this exported component secure, and some developer, they try to neglect this standard. So if they feel that the gate can be accessed from outside, means that the program is running, but not from the security point of view, means that they also exposing some vulnerability inside of their application. So the score is quite good here. The security score is 55, is more than 50%. So they have only one exported receiver, means that only one gate to receive some data exposed by the outsider. And they also have some signature mechanism. So since the version 1 is false, means that this application is signed by version 2 signature, and means it's not quite safe because the current version is version 4, means that this application is quite old application. Public key using quite long, as 2048 is quite safe. And then browsable activity means some application or some component inside of the application can be browsed. Usually, if you develop a mobile application using like a hybrid mode framework, such as React Native, and then convert it into mobile application, and that will create so many web frame that can be easily injected by the hacker. And they also mentioning about some vulnerability here. App can be installed on a vulnerable unpatched Android version because they not make some let's say regulation for the API series that can fit into this application, because maybe this is quite old application. And then this is the standard of this CPU, and usually only x86 and ARM CPU chipset. Okay, the rest is reporting, but the overall score is quite good. I mean, there's no some significant flow inside of this application. And they also have like a dynamic report, but seems that this application is not checked yet. The dynamic report is still inaccessible. Means they're not running the dynamic test yet. So other than the static and dynamic analyzer, one more thing. So dynamic analyzer, they're using some emulator, not using a real device. There's a few options like a Genie Motion and also emulator that coming from the Android SDK. And other than these two, they also have some API. So this API can help you if you want to analyze multiple application. Let's say that you want to analyze like a hundreds application. Automatically, you can use this API to connect to this live version. Or if you want to install it by yourself on your server, you can try to install it. So it will have like a local IP address, and then you just directing the path to that local IP address and send the API, send the request to that API in the local address. So it will be more easier to analyze multiple application simultaneously. So I think that's all from my side. If you have anything to discuss, I'll be happy to answer. Ms. Parker?
Yes, participants are requested. If you have any queries, then you may discuss. The mic permission is already given. You can unmute your mic and ask the question.
On behalf of Computer Science and Engineering Department, Anjuman College of Engineering and Technology, I extend our sincere gratitude to Mr. Budi sir for joining us and sharing his expertise despite being overseas. We thank you, sir, for your insightful session on security and privacy in mobile health application. Your expertise have truly enriched our FDP and provided us with a deep understanding of the vital area in the healthcare industry, technology, as well as the things, the tools that are available, that can be accessed, that can be used. So we are thankful for you to accepting our invitation for this expert talk. Thank you so much, sir. Thank you so much, sir.
Yeah, thank you very much, Ms. Parker. It's such an honor for me actually to share my knowledge with our colleagues from India. Yeah, hopefully I'll be there someday and visit your university there. Thank you very much, Ms. Parker.
Thank you, sir. Uh, Participants, if you have any queries, you can raise your hands. You can raise your hand if you have any query.
Yes, quite a lot of participants today, Ms. Parker. Are they a student or?
So all are from academics, so like faculties are there, and
Mhm.
in fact we have participants from medicine field
Mhm.
who are connected with us. Yes.
Yep, yep, yep. Yeah, I think there's no question. Ms. Parka?
Let me just check the chat box if any questions are there. Participants, if you have any queries, please raise your hand. Okay. Okay, sir. I don't think so. There are any queries, and okay, no. That participants are requested to submit the feedback form for today's session. I once again extend our sincere thanks from Anjuman College of Engineering and Technology, India.
Yeah.
Thank you so much, sir, and we hope to connect with you in future also for such programs.
Yeah. Thank you. Thank you very much, Ms. Parka. So means that there's no question. So I will ask your permission to leave
Yes, sir.
this event.
Yes,
Yeah.
yes,
Thank you very
yes.
much. And convey my greeting to all my colleagues in Anjuman. Is it school?
Thank you so.
College of Engineering and Technology.
It's a College of Engineering.
Yeah. Thank you very much. Have a good day.
Thank you, sir.